Dear students, this is the extended version of graphs of curves. The second part is only suitable for paper A students. So, quadratics and other curves. So, first a little bit of theory. When we talk about a quadratic curve, let me remind you, we've done this in the other lesson. Quadratic curves, there are two types of curves, the positive and the negative. The positive, which has this shape, the negative, which has the shape. A positive curve has a minimum a negative has a maximum. Both types, they have a line of symmetry. Sometimes they have solutions, roots, sometimes they do not. So if the curve meets the x-axis, there are solutions, one or two solutions. If it does not meet the x-axis, there is no solution at all. So you can't even solve that problem. Then we have the cubic curve. First of all, the cubic curve, the equation in the form y equals ax cubed. It could be plus or minus something. We have two types of those curves. Again, the positive and the negative. The positive has this shape. Sorry. The negative has this shape. Okay, so these are the axes. One is a positive, one is a negative. If our curve has other variables, other powers, x squared, x with it, then it might meet the x-axis more than once. Okay, so it's possible for a cubic curve to meet the x-axis more than once. For example, if we have, for example, ax cubed plus bx squared plus cx plus d, that might have three solutions which are in the form, for example, okay, where you have x1, x2, and x3 as your three solutions. Okay, so that might have a possibility of three solutions. That is a cubic curve. All cubic curves, they do not have any line of symmetry. Don't have lines of symmetry. Now, then we have also the inverse curve. Inverse curves, again, we have two types of inverse curves. Y equals a on x, or y equals minus a on x. In the first case, it would be something similar to this. In the second case, it would be something similar to this. Both curves, they never meet the x-axis, they never meet the y-axis, so they are always unsolvable, no solution. And as x increases, y becomes very close to 0. When y increases, x becomes very close to 0. So that's why they are inverse curves. They are inversely proportional. Both, they don't have any symmetry. They don't have symmetry. So that's about our curves. Now, sometimes you could be asked to answer questions on sketches, not on plots. Now, how do you sketch a curve? Sketching a quadratic curve. So to sketch a curve, you need to follow the following steps. Number one, you need to note if it's positive, minimum, or negative, maximum. This is the first thing which you need to note. Number two, you need to solve the equation to find the roots. Number three, you need to find the equation of the line of symmetry. Because a quadratic curve has symmetry, right? And that is always found midway between the roots. Midway between the roots. Point number four, you would need to find the coordinate of the minimum or maximum by using the line of symmetry, because the line of symmetry always lies exactly, passes through the minimum or the maximum. Number five, you can sketch the curve. You can sketch the curve. So let's see an example so that you would be able to see those steps being worked out. So suppose I have sketched the curve y equals x squared plus 3x plus 2. I need to solve how to sketch that equation. First of all, it is a positive curve, so it has a minimum. Number two, I need to find the roots. So the roots are, and I work it out, I solve it, x squared plus 3x plus 2 is equal to 0. That's a trinomial which is factorized. X equals 2, x equals 1. So x is minus 2 and x is minus 1. So those are the two roots. Those are the two values where the curve will meet the x-axis. Number three, I need to find the minimum, the line of symmetry, line of symmetry lies midway between the roots. So x equals midway between the roots minus 2 plus minus 1 divided by 2. That's minus 1.5. So x equals minus 1.5 is the line of symmetry. It has a minimum. We're going to find the minimum. Minimum coordinate is when x is minus 1.5, y is going to be minus 1.5 squared plus 3 times minus 1.5 plus 2. You work that out and it gives a value of minus 0.25. So the coordinate of the minimum is minus 1.5 minus 0.25. So now I can sketch the curve. So I know it is a minimum curve. I'm going to start from the curve. Okay, slightly better. Start from the curve. That curve, by the way, has a y-intercept of 2. Okay, so I know it passes from 2. It has 2 negative. So this is the x-axis. It has 2 negative, minus 1 and minus 2 roots. Its line of symmetry is x equals minus 1.5. So this is the y-axis and 2 is the y-intercept. Okay, the minimum coordinate here was minus 0.25. So that is the sketch of the curve y equals x squared plus 3x plus 2. If you want, you can work out a couple of these just form two quadratic equations, one or two quadratic equations, and you can then sketch their curves. Um, see again this part of the video so that you get accustomed to the steps which one needs to take to sketch a correct curve. Now that's about quadratic curves, sketching a curve. Now something else which you might need to use is solving an equation from a graph which you have already plotted. Okay, so solving equations from graphs. I'm going to give you an example. Okay, we're going to work an example so that you can see what I am talking about. So, for example, plot the curve y equals x squared minus 6x plus 8 for values of x between -1 and 7. Use your graph to solve the following equations. Number 1, x squared minus 6x plus 8 is equal to 0. Number 2, x squared minus 6x plus 8 is equal to 2. Number 3, x squared minus 6x plus 8 is equal to minus 2. Number 4, x squared minus 5x plus 2 is equal to 0. So those are, plus 6 is equal to 0. So those are our equations which we need to solve. We have to start by forming a table for x squared minus 6x plus 8 for values of x between -1 and 7. So I'm going to start with the table x between -1 and 7. Y is going to be equal to, you can use your calculator to form the table, of course. I'm doing it right now. So x squared minus 6x plus 8 start at -1 and at 7. Step is 1. So I have 15, 8, 3, 0, -1, 0, 3, 8, 15. Okay, be careful, make sure that you have a minimum point. In this case, I do have a minimum point. That's a very important value. So now I'm going to plot the graph. So range of values of x. Range of x was between -1 and 7, and range of y between -1 and 15. I do that so that I would know how to divide my graph. So I have between -1 and 7 and between -1 and 15. So this is 0, -1, 1, 2, 3, 4, 5, 6, and 7. This is -1 to 15, 2, 4, 6, 8, 10, 12, 14, 16. That's y. -2. That's x. So I'm going to plot the table. Okay, so I have -1 with 15. 0 with 8, 1, 3, 2, 0, 3, minus 1, 4, 0, 5, 3, 6, 8, and 7, 15. So there's our curve. Okay, there's our curve. There's the curve for y equals x squared. Remember the graph, minus 6x plus 8, minus 6x plus 8. Okay, so that is our curve. Now we can start answering our questions. Okay, so the first question was x squared minus 6x plus 8 equals 0. Equals to 0 means that is the place where the graph meets the x-axis, because this is the graph which we have plotted. So the curve, as we can see, the curve met the x-axis at 2 and 4. So the answer to that question is x equals 2 and x equals 4. That's very straightforward. Normally it carries 1 or 2 marks. Now, the second question, x squared minus 6x plus 8 equals 2. X squared minus 6x plus 8 is the same x squared minus 6x plus 8. This is equal to 2, but this is equal to y. So y is equal to 2. We go on our graph. We draw the line y equals 2. I am going to draw the line y equals 2. Y equals 2 is this line here. And I notice where that line meets the curve. It meets the curve at this point and at this point. This is 1.25. This is 4.75. So my two answers are x equals 1.25, x equals 1.25, and x equals 4.75, I think it was 4.75. Those are my two answers. Now the second one, the third one, x squared minus 6x plus 8 equals minus 2. X squared minus 6x plus 8 is the same one. Now this time it's equal to minus 2. So y is equal to negative 2. I'm going to do the same thing as we did before. I will draw the line y equals minus 2. This is the line y equals minus 2. Okay, y equals minus 2. And as we can see, the line y equals minus 2 and the curve do not meet. It means that we have no solution to this part of the question. It has no solution because the curve and the line did not meet. Now, the fourth one, this time x squared minus 5x plus 6 is much different from x squared minus 6x plus 8. So what we are going to do, I'm going to work it out here. So I have plotted x squared minus 6x plus 8 equals y. But we need to solve x squared minus 5x plus 6 is equal to 0. So what are we going to do? We need to use this equation and make it equivalent to the other equation. Because this has already been plotted, it can't be touched. So what am I going to do? Minus 5x, I need it to become minus 6x. I can do that by subtracting x. But this is an equation. If I subtract x from one side, I have to subtract x on the other side. Same thing here. I need 6 to become 8. That means I need to add 2. But if I add 2 to one side, I have to add 2 to the other side. So the equation is y equals minus x plus 2. Now I need to plot minus x plus 2. I go my graph, minus x plus 2. It passes through 2, and it has a gradient of minus 1, meaning going down 2, I move 2. So it passes from there, it passes from that point. I can draw the line. That is the line y y equals minus x plus 2. And that line meets the curve at 2 points, at 2 and at 3. So the answer to this part of the question, x equals 2 and x equals 3. Okay, so that is the last part of this topic. What can be different? Instead of having a quadratic curve, you might have a cubic curve or an inverse curve, but to work it out, it's always the same problem, and you need to work out approximately the same type of working. Thanks for your attention.